increases with group from top to bottom due to the addition of new shells in successive periods and shielding effect of electrons. Trends of atomic radius in periods. The atomic radius decreases in the period from left to right due to addition of electron in the same shell. As the number of electrons increases, the number of protons also increases. With increases, the nucleus pulls on the electrons and pulls them nearer to the nucleus, thus the atomic radius decreases. Covalent radii. The one half of the distance between the nuclei of two similar atoms of the same molecules containing a single covalent bond. Therefore, the bond distance between the two atoms A and B is the average of the length A to A and B to B. Ionization energy or ionization potential. When an electron is completely removed from the valence shells of an atom, we say that the atom has been ionized. This process is known as ionization, which needs energy. The process of ionization can be represented by the following general equation. The minimum energy required to remove the valence electron from the outer shell of the gaseous atom to form the positive ion is called ionization potential or ionization energy. Ionization energy of an element is measured experimentally in joules or kilojoules per mole. For example, the first ionization energy of sodium and magnesium is represented by the equation. The above two values for sodium and magnesium are called the first ionization potential for sodium and magnesium respectively. The energy required to remove a second electron after the removal of first electron is called second ionization potential. Magnesium's second ionization energy is represented. It is observed that ionization energies of an atom depend upon several factors. These are atomic radius of the atom, nuclear charge of the atom, shielding effect of low-lying electrons, electronic configuration of the atom. Trend of ionization potential energy in groups. Atoms with smaller atomic radii, greater nuclear charge of the pore shielding effect have usually high electron affinity value. Trend of electron affinity values in the periodic table. The electron affinity in the groups. When we move in a group from top to bottom in periodic table, the electron affinity decreases. The decrease in electron affinity is due to the addition of new shells. These shells make a shield between the nucleus and outermost shell, and force of attraction between the nucleus and valence electrons is reduced. Therefore, the tendency of taking electron is decreased. The electron affinity in periods. When we moved in a period from left to right, the electron affinity increases. This increase in the electron affinity is due to increase in the nucleus charge and decrease in the atomic radius from left to right. Therefore, the tendency of taking electron is increased. Electron affinity. Electron affinity means love or attraction of accepting electron. All these elements in the periodic table possess varying tendencies toward the acceptance of electrons in their outer shell. The new incoming electron, when absorbed by the atom, is slightly bound by the nucleus of the atom through attractive force. This causes an evolution of energy. Thus, the electron affinity of the atom is measured in terms of energy. The minimum amount of energy released when an electron is added to gaseous atom of an element in its outermost shell to form an anion is called electron affinity. It is represented by EA. It is assigned negative values and expressed in kg/mole. For example, the energy released by addition of the first electron is called the first electronic affinity. The energy released by the addition of the second electron is called the second electron affinity. By addition of the first electron, the energy is released, but the addition of the second electron requires the absorption of energy. This energy is required to overcome the electron repulsion, for example, nuclear charge, atomic radius, shielding effect, electronic configuration. Electronegativity is a property associated with atoms when they are chemically bonded to each other in a covalent bond. The two atoms involved in bond formation mutually share their electrons. This shared pair of electrons is then attracted by the nuclei.